Hello, this is Dev Tigris and welcome to my JavaScript HTML5 game development tutorial number 10. In this tutorial, we'll animate the dog sprite in all 8 directions using the keyboard controls. This is different from our basic controls demonstrated in the previous tutorial in that the actual frames of the animation will change based on which keys are pressed on the keyboard at that time. And also, we will check whether 2 keys are pressed at the same time, and we'll adjust our animation according to that direction. And remember, this is the sprite sheet that we will be working with. For demonstration purposes, I'm going to go ahead and grab one frame from each sequence. I'll arrange the first 4 directions like these. So we have left, right, up, and down. And just as you would on a compass, we would have these directions named north, south, west, and east. And of course, in addition to that, you have diagonal frames that go in these places. And in the same way, we'll name them northeast, southeast, southwest, and northwest. And this will help us writing the code. Now, when it comes to the code, we will first take care of the left, right, up, and down directions, and then we'll add diagonal directions. In other words, if 2 keys are pressed at the same time, we'll go to one of the diagonal directions. And I'm going straight back to our previous example where we have a bunch of dogs rotating and using all kinds of different ways of animating our dog object. And I'll leave that one out. I'll save the project and refresh the browser here. Okay, we got the dog moving, but now we need to apply all of the different directions. Try to avoid using copyrighted images in your published games, but for experiments and demos and learning how to program, it's totally fine. You might be an artist yourself and you probably would be able to create some basic sprites in the sprite sheet, but don't forget that there are resources out there to experiment with. You can use them to test your game out and see how it plays with actual characters. I'm a little hesitant of using copyrighted material in my tutorials, but this is just the Google image examples just to show you that the content is out there to experiment with. And again, you might want to learn how to draw pixel art. A lot of the characters in some independent video games are very simple, and if you feel like it's something you could be doing in addition to writing the code, there's no reason not to experiment with something like that. That is exactly how I created my dog sprites, and the great thing about that is that it might take a few days to draw some really good animation frames and figure out how to do that. Not only you will be learning how to draw your own sprites and animate them, there'll be original sprites in your game, which is a hugely valuable asset to have. And now we're going back into the code. What we'll do, we'll simply write the code that will animate our already controlled dog, and we'll track if multiple keys are pressed. And if that is so, we'll simply use a different sequence for the dog animation. You can use any sequence in the sprite sheet that we want, and that's exactly what we're going to do. And so remember that the animation sequences that we'll be using will simply be grabbing one of these series of animations, and they're all tied together by IDs. And an ID in the sprite sheet is nothing more than just a linear representation of the values that starts from 0, goes all the way down to 63. So we have 64 values in total. Mapping the IDs onto the sprite sheet could be a little tedious, and for that reason, in the future, we should probably develop some tools to accomplish that. But for now, I simply drew this in Photoshop. And because we're going to do left, right, and up and down animations first, I mapped out these sequences. So going right would be 1, 2, 3, 4. Going down would be 17, 18, 19, 20. Going left would be 33, 34, 35, 36. And going up would be 49, 50, 51, and 52. And these are simply the values we will pass into our animation sequence arrays. Of course, the ones in between here will be used for diagonal directions, such as 25, 26, 27, and 28 will go southwest. And you'll figure out the other ones. I think that's obvious by now. At this moment, we got really close to writing the code for controlling our characters in 8 different directions. But before I go into the code, which would take about 2 minutes to complete, I'd like to talk about bitwise operators. Bitwise operators are incredibly useful for many things when it comes to game development. I'll use this opportunity to show you how they work, and we'll implement our keyboard controls with the animated character, which will be running in 8 directions and animated using a different set of sequence for each direction. And bitwise operators are great for this task because at the core of bitwise operators when it comes to game development is the ability to store multiple states in a single variable. And once we go over how they work, I think it will make a lot more sense. Usually there are 6 common bitwise operators, and they are displayed on the screen right now. And in this keyboard controls tutorial, we'll only use 2 of them. They are now highlighted on the screen. The first operator we want to look at is the OR operator, and the calculation table looks something like this. So usually bitwise operators work on 2 bits. So here we have bit A and bit B. Each bit can only be 0 or 1, so there's a limited number of operations that can take place. But the key thing to notice here is that 0 ORed to 0 equals 0. 0 ORed to 1 equals 1. 1 to 0 equals 1. And 1 to 1 equals 1. Basically, what it's really telling us, as long as there's at least 1 bit that is equal 1, the result will always be 1. I'll present really simple examples that will show you how these operators work and what we can get out of them. So let's start with the bitwise example. Let's assume that our first number is something like this, and our second number is something like that. So these are both numbers in binary format. What would happen if we apply the OR operator on both of them? Let's draw the line to see the result of this operation, and the result will be equal 0, 0, 1, 1. Applying an OR operator on both of these numbers will finally result in this number 0, 0, 1, 1 in binary format. It's a lot like regular multiplication, where you have one number underneath another, and this is the result of this operation. Now, how something like this could be possibly useful, we can specify different terms for different values. For example, let's say that this value would be equal south as far as directions on the keyboard go, and this value would be west. So when we combine the 2 values using the OR operator, notice that we now have both of them in one variable, in one number stored. And that would mean that this value would contain southwest direction, which is a combination of these 2 values. So instead of using 2 different variables for south and one for west, we can do all of these calculations within one variable, which would really make our code a lot more cleaner. And so just to add a little note here, Bitwise OR operator is used for writing multiple states into a single variable. And again, in JavaScript, these binary numbers can be represented by regular variables, and you will see how that's done in the next part of this tutorial. But first, let's now go over the AND operator, which will allow us to read these values back into other variables or some sort of a result value that can be then used in an if statement, for example. Let's say that we now have this 0011 in binary format and it represents Southwest. So how do we read it back into something that can be compared within an if statement or elsewhere? To do that, we use the Bitwise AND operator. Let's take a look at the table for the AND operator, and it looks something like this. So when both is 0, the value is 0. When at least one is 0, the value is always 0. So it's the opposite of the OR. And the last one, if both are 1, the result is 1. This dynamic will allow us to read back the values that were set with the OR operator. Sometimes in programming, we say two values are ORed together. And now let's read them back using the AND operator. So let's take this value that we calculated. We'll start with the same value that we just created using the OR operator. And we know that it stands for Southwest. Of course, as you may know, these flags don't have to be used only for keyboard controls. This is just this example. These flags can be used to store any game information for your game characters or some other values, for example, game states. And usually when the value is set to 1 at one particular location within that bit, then that usually means that that value is set to on. If it's 0, it's set to off state. In this particular case, West is set by the second bit right here. And so in order to check if it's present, we need to check for this value. And if we AND both values here using the Bitwise AND, the result will be 1 if that value is present within the original value. In other words, we're checking for the presence of this 1 bit in the original value by ANDing it with the value that represents that bit. And if this results in 1, as this table suggests, then that means that that value is present in the original variable. In this example, we're checking for the value West if it's present. And let's take a look what the result is. In this example, the value is of course present, and the result is the same value that we passed for checking. And so with this, we can conclude that the AND operator is used for reading a single state from variable containing multiple binary values. Now that we know all of this, writing the controls code and animating our character becomes really simple. Let's go back into the code. I'm going to make it a little bigger here so we can see what the code is actually doing. Remember that from our previous tutorial, we're left with this simple keyboard control dog sprite that's currently being animated in one direction. So using the Bitwise OR and AND operators will make this animation match which keys are being pressed at that time. This will result in a really cool way to control an animated character, and all of the animations will properly match the direction in which that character is moving at that time. Remember that we're working with binary operators here. That means that the way in which we determine state variables must be done a certain way. Again, I'm not going to go into entire explanations of binary format and how it works. You can look it up elsewhere, but I will indicate visually how it works. Each binary number has an equivalent of itself in the decimal format. For example, the binary number that contains all zeros, is actually 0 in decimal as well. The binary number 1 would also be 1 in decimal. In binary format, we can only use 0 and 1, so moving that 1 bit to the left produces 2 in decimal. So far we have 0, 1, and 2, but this is where things get a little interesting. The next binary number is 4. Of course, you might probably think, where's 3? And why is 3 missing? Well, it is there, and it can be represented by binary numbers, but we're only looking for binary numbers that contain only 1 digit within the entire set. And that is because that's how we create our flags. For example, the next one, you guessed it, the one would be here. Let's take a look. And in decimal, this binary number is 8, because see how all of these zeros are empty, and there are actually many more binary combinations that are possible here, and these combinations determine all the numbers in between 4 and 8, but at this point we're not looking for them. And if we continue going to the next binary number that contains only 1 digit, 1 bit set through the entire binary value, we'll see that the next value is decimal 16. And if we keep going like that, the next one is 32. The last one in this example is 64. The one after this one would be, I believe, 128. And so what I'm saying is, in order for our binary bitwise operators to work, we need to use all these values in decimal format. And these will be the values we will assign to our variables for different states. In this case, it's the keyboard movement in 8 different directions. So 0 would, for example, be going south, and 1 would be southwest, 2 would be west, and so on and so forth. But notice how we use these values that are represented by these numbers in decimal format. Using other decimal numbers, for example 3, which would be 1, 1 here, would simply not work in terms of using our OR and AND operators to add and look for different bits in the same value. So keep that in mind, that these are usually the numbers that we'll use for different states. I'm adding 128 to be complete. Remember how we have 8 different directions and animation sequences. So each one of these states will equal a direction on a compass, you can say, where we have east, northeast, north, northwest, and so forth. We're going to leave 0 alone here because it's not really a state and cannot be used as one, because using bitwise operators on 0 always results in 0. So we have these 8 values nicely mapped to all of our bit flags here, and each one of them will conveniently represent a direction of our sprite character. Having said all of this, let's go back into the code, and knowing what we know now, let's simply write the code. Now let's go into our keyboard JS file and add these binary values and store them as separate values here in variables. And E, notice I have to go in circular direction. In other words, east, then northeast, northwest. So this one would be 8. Their W would be 16. Southwest would be 32. South would be 64, and the last one, southeast, would be 128. So we have finally applied all of the states to different direction variables. And by doing that, we have determined the decimal values for each binary number as seen in our previous diagram. Now let's go back to our main game file and let's write some code to animate the character. We already have the dog movement added to our left, right, up and down keys. One more thing that we need to add is a variable that will tell us whether the dog is moving at that current time. Let's go ahead and is moving. Usually it's false by default. Let's copy and paste that into our if statement. And here where we draw the animated dog character, we'll simply say if dog is moving, then animate it in some ways. And else, if it's not moving, let's simply draw the dog in its original sitting position or standing without any animations. And that was the frame 0 in our sprite sheet. Remember, because the dog object was created from a sprite sheet, whatever goes in here, and if it's not an array, it will simply use a single frame, as explained in the previous tutorials that dealt with constructing the entire animations sequences. I'm going to go ahead and refresh the browser, and we'll see that the dog is now not being animated, and this thread in our if statement is being executed. And if we move the dog right now with our keyboard controls, it will simply slide without any animations at all. So let's go ahead and add that in between this statement right here, and let's go ahead and change this line and adjust it so that we can actually play all the different animation sequences for all the directions. Again, remember in keyboard.js we determine all of these binary states using decimal numbers that need to step in power of 2. So there's 2, 4, 8, 16, 32, 64, and 128. And now we're going to actually use these flags that we have created to construct our animation. The first thing we want to do is we want to take the dog is moving variable and reset it on each frame to false. And to each of our keys here, we need to add, so in other words, if any key is pressed, obviously the dog is moving. So we're going to add this value here and make sure that it's true whenever any of these keys are pressed. I'll refresh the browser, and even though we only have one frame, you see that when I'm pressing keys, the dog is being animated. Otherwise it's just sitting, and that's exactly the effect that we were trying to achieve. Now let's go ahead into this part and add all of the other states. Now remember how we used the binary bitwise OR operator to add in all of these states into a single variable. And so let's create that variable for the dog, and that variable will be called dog direction. And let's originally set it to 0. I'm going to copy and paste it into our main loop. And in the same exact way, you want to reset the dog animation, the dog direction to 0 on each frame. And every time a key is pressed, we will associate those flags that we created in binary format and add them into this one variable that will hold our direction for that animation. I'm going to do it in this way. So if we're moving left, that's west. So I'm going to use the OR operator to add that direction. And again, let's look up. Used to be direction west, and we're using that right here. In the same way, we can add in all the other ones. So this one is right, and we'll use the direction east. I'm going to copy and paste this to speed up the process. This one will be up, so that's north, and this one is south. So we have all these 4 directions covered. That means by the time these key presses are registered, we'll know by checking this one variable whether these values are present. And that's the convenience that's provided by the Bitwise OR operator. The whole point behind this is that this one variable will allow us to check whether multiple keys are pressed without having to use multiple variables. And so now that we have all these potential directions stored in one variable here, we can check whether that value exists at the same time with other values. And that will help us determine whether the dog is moving in multiple directions at the same time. And as mentioned earlier, to do that, we use the AND operator. And that's the AND operator that we're going to be using in this part of our code to determine which sequence to actually play. At this point, we can probably create a new variable called dog sequence, seq. And at this moment, I will say 0 for nothing because nothing has happened at this time. And within this loop, we will check the dog direction variable for the presence of the direction, I would say west, as one of the first ones. And again, all we have to do is apply the AND operator to the direction bit to find out if it's present. So if this evaluates to true, then we know that the left key has been pressed. And so we're not drawing the dog yet, so I'll delete that. What we want to do is we want to take the dog sequence variable and apply the sequence to it, and that was 1, 2, 3, 4. And so that will happen if the dog is moving west, and instead of the sequence that used to be hard-coded, we can now use the variable sequence here. And finally animate the dog. Dog. I'm gonna bump this up a little like this, and we'll replicate all of the other directions: west, east, north, and south. And of course, we need to plug in the sequences here from a previously shown table. And so the one for west would be from 33 to 36. So let's go ahead and do that for this variable. 33, 32, 33, 34, 35, and 36. Let's go ahead now and look up the one for north, and that would be 49 and other ones. So let's plug them in here: 49, 50, 51, and 52. And the one for south, let's go back for a second here. And the one for the south would be, that starts with 17. So let's go ahead and type it in here: 18, 19, 20. And just to test what we have so far, I'll simply refresh the dog here, and as you can see, the animations are actually changing. I only have 4 keys covered, but it's properly playing each animation, and it looks a lot better and more realistic here. Now we just need to get the diagonal ones, and it's done in exactly the same way, except for the diagonal ones we need to do double check whether the dog direction is, for example, if we want to move north and east at the same time, of course we would check for northeast, but we have to do it one at a time, and we would do direction north. Then we use the regular AND operator. It's different than the bitwise AND, using the double AND character. And we check for whatever direction we want, northeast, for example. And in that case, of course, we need to go back to our chart here to see northeast. Northeast would be the one that starts with 57. So we apply that sequence. 57, 58, 59, 60. And we can probably adjust it like this for now. And in the same way, we want to copy and paste this 3 times more and determine the other ones, northeast and northwest. Gonna look it up again. Northwest would be, so that's north, that's up and left. So it's the one that starts with 41. Let's go ahead and plug that in. 41, 42, 43, 44. And now we want to do the same thing east and west here, like in the previous examples, but change this one to south in both cases. And then in the same way, we want to look up southeast. Southeast would be down and right. So that would be the one that starts with 9, 9, 10, 11, 12. And the southwest would be southwest, the one that starts with 25. Plug that in. 25, 26, 27, 28. I'll save all of this and refresh the browser. Now, whenever I use multiple keys, that animation is being looked up correctly, and the dog is moving in circular fashion. It looks really great. It covers all of these 8 directions. It works properly. And basically, by implementing this code, this is how you would do it for any character. You would just keep these arbitrary parameters for each sprite. It would be covered later on in my tutorials, how we can hide these variables by creating a generic player character object later on in my tutorials. But so far, we've done some really good progress in terms of moving the animated characters on our screen using keyboard. Thanks for your time, guys, and looks like another tutorial has come to an end, and I'll look forward to see you in my next tutorial. You have just watched another installment of game development tutorials by Dev Tigris. That's me. If you want to be reminded when my next tutorial is out, you can do so by subscribing to my YouTube channel. This is usually done by clicking on the subscribe button right underneath this video. I appreciate everyone's time, and I'll see you in my next tutorial.